Hello everyone, I am Mohammad Atif. Now I am going to talk about Linux memory management. Virtual memory layout. A closure lock application require memory with different properties. Access permission, sharing, file backup was anonymous, dynamically sized. Managing virtual memory. Some designs consideration. Virtual address space is quite larger for 64 bits. Uh, cannot assume virtual address usage size, efficiency, currency, CPU and memory. Address space requirements harder structures, MMU. Managing virtual memory, user space address, virtual memory space management alternatives, contiguous allocation based on memory regions type, inflexible issues. Spare allocation, a sorted list of used range celebrity issues can be solved using balanced search trees. How Linux does it? This is the example that how Linux does it. Start and end never overlap between two VM areas. Can merge VMS in permission match. Linux maintains both BR trees and a stored listen CMM file map PC. Example usage, and these are the example of an usage. Demand paging background. Why not use physical addressing? Considering application expectations of virtual address space flexibility. Why not use segmentation only design? Why use paging? 4 level paging tables, 48 bits virtual address, and this is the example of 48 bit virtual address. And for wall page table in operating in yes, system windows for fun and profit. Page table transliteration bay data. Multiple page size support 4K, 2M and 1G. Some processors can have multiple page size. All depends on page table is organized. Strategy. Collapse page table starting from lowest level. Recharge and huge bit BSP PS bit in page table enters. What are the challenges? This is the paging with multiple page size. Example: page fault, synchronize or asynchronize. When can it happen? When are the triggers? Do we require any information regarding the fault? Ask what and why. When can it happen? What are the triggers? Why do we require page in soft? Page fault handle. Page fault is an exception. Translation missing in any level of package table hierarchy. Translation present but access right do not permit access. Error code provided by CPU. To distinguish the above scenario, page fault handling. CR2 registration in X in into 86. Perform software walk to check missing entries. Allocate missing entries in the page table hierarchy. May require new physical allocation. Code reference. And this is the code reference. What about the virtual address? Addressing in kernel. Kernel executes on behalf of kernel states it assemble from all process in kernel mode. Alternate one during process Entry into kernel change the page tables. Alternate to kernel memory mapped to over across page table over across page table. Props and cons. Multiple monolithic kernels. Every process has the same heart. This is the example of monolithic kernel. Kernel virtual address mapping should be present in both process. Linux strives on family values. A child process page table inherits kernel mapping of the part by implication. The entire tree is rooted at the first process. A possible solution, and this is the possible solution: one or more enters in PGD level 4, average code by one enter. How many entries? A possible solution, PG2, a possible PG2 is copy of PG1. Thank you.